Okay, now for this example, we're supposed to write a fourth degree polynomial equation in standard form with zeros of 5, 11, and 3 minus I. So already, fourth degree, I should have 4 solutions. So I'm going to go ahead and write x equals 4 times, and then figure out what my 4 solutions are. Okay, zeros of 5, so x equals 5, 11, 3 minus I, but what's the 4th solution? The complex conjugate root theorem says if I have a complex number as a solution like this one, that means its complex conjugate will also be a root. So 3 plus I will also be a root or a solution. I've got my 4 solutions now. Okay, we're going to turn these into factors, so go ahead and pause the video and write your factors. So here's my factors. One thing I do need to point out to you is I have x minus 3 and then plus 2i, x minus 3 minus I. So this minus 3 is in both of them, which means I have that minus 3 is on both of them. You'll notice that I have a plus I here, minus I here. So it's only the imaginary part that changes. I have seen so many times when someone will put a minus 3 here, no problem. But then they'll put a plus 3, and that just screws it all up, so don't do that. Okay, so we're going to take these and we're going to multiply them together. And you might wonder, does it really matter what order we multiply in? It doesn't matter what order you multiply in, but you might wish you'd multiplied using some kind of a strategy. So I would recommend that you multiply real factors with real factors and imaginary or complex factors with other complex factors. It will make your life easier if you do it that way. So I want you to multiply each of those 2 sets of numbers, and then we're going to come back and see what our products should be. Now before I reveal what our final answer should be on this one, I want to point out that when we're multiplying complex conjugates, that the row in the column that has the I part, that 4 out of 5 of those terms are going to end up adding up to a 0. So I don't have to do anything with the row or the column that has the I in it, except for pay attention to this box right over here, because in that box I have a negative I squared. Now I remember that I squared is equal to negative 1. So this is saying the opposite, whoops, sorry about that. This is saying the opposite of negative 1, which is positive 1. So this box actually has a value of positive 1. I can add that with my 9. I can add these 2 together. They will not cancel out. So when all of that has been simplified, I have x squared minus 6x plus 10. So now I've taken these 4 factors and I've condensed them into 2 factors. So now I've got to go ahead and multiply this trinomial times this trinomial, and we're going to see what we get here. This is going to require, for me, I'm going to use a box that's 3 by 3. We're going to see what we end up with. As you can see, these are all the terms that I get when I multiply my trinomials together. I have 9 terms. I need to condense them into a simplified standard form polynomial. So I'm going to start with the term that has the highest degree, which would be this one, and I'm then going to combine my like terms so my third powers can go together. I can then put my second powers together. It's very nice that they're on those diagonals. I appreciate that. And then I've got these linears, and then I'll have that constant there at the end. So let's go ahead and combine our like terms. Let's see what we get. So this is what I get as my final answer. It's my standard form equation. I did check in my calculator. I put this expression here into y1 equals. I checked for on the table when x was equal to 5, I got y was equal to 0. When x is equal to 11, y is equal to 0. I can't check these imaginary ones in my calculator, but since these solutions were there, I'm going to assume that the others were there. So this is my final answer to that example. And this is one of the most complicated that it's going to get. The only thing we could do to make it even more complicated is if I had more solutions or more roots. The more solutions we have, the more times we're going to have to multiply through. So I hope you learned how to do this well. Thank you for coming in and watching this video.